Right, good day, Matrix. We're just going to do a question from the St. Andrews. You should have the St. Andrews 2016 paper with you, Prelim paper 1. And we're going to do question 8b, 9, and question 10. Let me just quickly share the screen. So, question 8a, okay, is not part of the syllabus. Okay, so don't worry about that. Okay, then let's have a look at question 8b. So question 8b says, okay, p of x, p is equal to square root of x squared minus 9 over x squared minus 2x minus 8. And the first question is, where is this thing equal to 0? And the next one is, where is it undefined? And where is it unreal? I prefer non-real to unreal, but same thing. Okay, so those are all the questions we got asked with regard to that. So, first of all, where is it equal to 0? Well, something will be 0 if the numerator is, remember, 0 divided by something is 0. Okay, whereas anything divided by 0, if you divide by 0, you fall in the hole, and it is undefined. Okay, those are your key concepts being tested here. So first of all, for this whole thing to be 0, this will be 0 when the top part is 0. In other words, when x squared minus 9 is equal to 0. So it'll be equal to 0 when x squared minus 9 is equal to 0. So when x minus 3x plus 3 is equal to 0. So when x is equal to 3 or x is equal to negative 3. Okay? Right. Then, when will this thing be undefined? Well, the key idea with undefined is if you divide by 0, it's undefined. So it'll be undefined when x squared minus 2x, if you divide by 0, that term is going to be undefined. When that is equal to 0, that factorizes to x minus 4x plus 2. So in other words, when x is equal to 4 or x is equal to negative 2. Okay, so that's when it's going to be undefined. And the key concept of something being non-real is that the square root of a negative is non-real. Okay, so in other words, when we're, and this is a common way that they test quadratic inequalities, if what's under the square root is non-real, is negative, it will be non-real. So in this case, it will be non-real when x squared minus 9 is less than 0. To solve a quadratic inequality, factorize it. X minus 3x plus 3 is less than 0. Remember, you want to know where it's going to be negative. Your x-intercepts are going to be 3 or negative 3. So if you've got, it doesn't matter, you've got to get the intercepts, it's going to be a positive parabola always. Okay, and you want to know where the function is less than 0, which happens over here. Remember, the answer appears, we want to know the x value, so you can highlight, there's your answer on the number line in green, and it's less than, so it's going to be an open dot, open dot. So there's your answer in green on the number line, and then you just got to either write it as an inequality or an interval notation. So an interval notation, it will be negative, you can't include the n numbers when x lies between negative 3 and 3, or you could write it as x is greater than negative 3, less than 3. Remember, arrows point to the left. Right. Okay, good stuff. Okay, then let's have a look at question 9. Question 9 says, okay, there's a 63% chance it will rain on any given day. Child has a 12% chance of falling in dry weather, and it's 3 times as likely to fall in wet weather. Okay. So in other words, it's a 12% chance of falling in dry weather, and that's 3 times, it's 12 times 3. So falling in, this is question 9, falling in wet weather, will be equal to 12% times 3, which is 36%. So you've got a 36% chance of falling, child will fall in wet weather. Okay, so now we've got a tree diagram, draw a tree diagram. So there are 2 scenarios. First of all, okay, is it going to rain or is it not going to rain? Okay, so you've got rain, not rain. Okay, and then you've got to remember, you've got to fill, when the tree diagram, you're going to fill the probabilities on the branch. There's a 63% chance it will rain, so that's 0.63, and there's a 37% chance it won't rain, so that's 0.37. Okay, so 0.63, 0.37. Then if it rains, the kid may fall or not fall. And likewise, if it doesn't rain, they may fall or not fall. Okay? On a rainy day, the probability that it rains that the kid's going to fall is 36%. So that is 0.36. And if I go 1 minus 0.36, that's going to be 0.64. Remember, each sub-branch has to always add up to 1, right? So 36% chance it will fall. But on a day when it doesn't rain, the chance of falling is 12%, which is 0.12. And 1 minus 0.12 is 0.88. Right. So we end up, okay, that's our tree diagram over there, and that's the 3 marks. Then question B says, what is the probability that a child will not fall on any given day? Okay. So not fall follows 2 routes. It can either rain and not fall, or it cannot rain and not fall. So those are my 2 paths, and we're moving along. It's something and something, so we're going to times it. Okay, so to get to here, just put it over here. So the probability that the kid will not fall is going to be equal to probability of rain and not fall, or probability not rain and not fall. You don't have to write the step down. So probability of rain and not falling is going to be 0.63 times 0.64, or is plus, or the probability of rain not falling, which this root over here, is 0.37 times 0.88. And if you shove that all into a calculator, you should get an answer of 0.7288. Okay, so there's a 73% chance roughly of the kid falling, of the kid not falling on any given day. Right. Question 10. This is on your formula sheet. So you've got probability of A is equal to 0.4. Question 10. Probability of A or B is equal to 0.7, and the probability of B is equal to K, right? Okay, so in the scenario over here, okay, what have we got? Well, what links up these things? Okay, well, first of all, okay, the first question says, sorry, when are events, find the value of K such that A and B are mutually exclusive. Okay, so here's the question. Okay, let A and B 2 events in sample set. Probability of A is 0.4, A or B is 0.7, B is equal to K. For what values of K are A and B mutually exclusive? That's the first question. So the key idea, okay, so is we've got to find K if A and B are mutually exclusive. Mutually exclusive. What does mutually exclusive mean? It means they can't happen. It's impossible for them to happen at the same time. On a Venn diagram, mutual exclusivity looks like that. Okay, they can't intersect. Okay. Remember, complementary means they can't intersect, but they take up all of the sample space. That'll be A dash and A. Okay. So now I've got to go and find K that they're mutually exclusive. The key idea, if you see mutually exclusive, for mutually exclusive, the key idea is that the probability of A and B must be equal to 0. Okay, that's what's going to happen if things are mutually exclusive. Now, if you look on your formula sheet, you've got something that says that the probability of A or B is equal to probability of A plus probability of B minus the probability of A and B. Now, we've got to go find K if they're mutually exclusive. So if they're mutually exclusive, the probability of A and B must be equal to 0. Okay, and we know that the probability of A or B is 0.7. So I've got 0.7. We know that the probability of A is 0.4. Probability of B we've called K. We've got to go find that out. And that thing is going to be 0 now. Okay, so we've got to just go solve for K. So I get 0.7 minus 0.4 is equal to K. So 0.3 is equal to K. So K is going to be equal to 0.3. So I check I got that right. Yep. Okay. So in the mutually exclusivity, there's no intersection. That's the key idea. Mutually exclusive probability of A intersection B is equal to 0. Independence, the next question says go find K. What values of K are A and B independent? And for independence, the key idea, independence means you can't really see independence on a Venn diagram. Okay, but independence means that the one thing doesn't affect the other thing. Okay, so the test for independence is what you expect to happen, the probability of A times the probability of B, okay, equal to the probability of A. That's how you test for independence. So if you're told they're independent, that must be happening. Okay, if you're asked to go prove They usually use contingency tables. Are two things independent? Show independence, you've got to show that. Okay? But if you're told they're independent, you can assume that. So we're told they're independent, so we can assume that. So if I go to this formula again, okay, probability of A or B is equal to probability of A plus probability of B minus the probability of A and B. I can replace the probability of A and B with the probability of A times probability of B. So, and I've got the probability of A or B is equal to 0.7. The probability of A is 0.4. The probability of B, we've got to find that's K. And it's going to be minus the probability of A and B, we're going to write as probability of A, which is 0.4, times probability of B, which is K. So that's that bit over there. And now we've got to just go solve for K. Move that across, I get 0.3 is equal to K minus 0.4K. And K minus 0.4K is going to be 0.6K. So 0.3 is equal to 0.6K. And 0.3 divided by 0.6 is going to be a half. So you're going to get K is equal to a half. So that's if those events are independent. And that is question 8, 9, and 10 done. Okay. All right. Let's have a look. And stop recording. Stop recording.